Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 problem of the week video, and this one is about using Stewart's theorem, similar triangles, and trapezoids to solve the problem. So without further ado, let's get on with the video. This is AMC 12B, problem 11 of the year 2021. Triangle ABC has AB equals 13, BC equals 14, and AC equals 15. Let P be the point on AC such that PC is equal to 10. There are exactly 2 points, D and E, on line BP such that quadrilaterals ABCD and ABCE are trapezoids. What is the distance of DE? And here are your answer choices. So the key words here are that it tells you the three sides of this triangle ABC. And then it tells you that P is a point on AC and that PC is equal to 10. So it also states that on line BP, there are 2 points D and E, so that ABCD and ABCE are trapezoids. And so we're trying to find the distance of DE. So the first thing we need to do is try and draw an accurate diagram. So that's what I'm going to do right now. It's a diagram right here, and we know that this is 5 and this is 10, and then that this is 13 and this is 14. So I drew two trapezoids, ABCD and ABCE. So in the trapezoid ABCD, it is the fact that AD is parallel to BC. And then in trapezoid ABCE, we can see that AB is parallel to CE. Since these two lines are parallel to each other, the angle ABE is equal to the angle BEC. And these two angles are obviously equal to each other. And then so that means these two angles are also equal to each other. So these two triangles are similar triangles. Similarly, we can see that in trapezoid ABCD, the triangles APD and the triangle BPC are similar to each other. Because we know the triangles ABP and the triangle CPE are similar to each other, so we know that these two triangles are similar, and so they have a type of ratio between these two triangles. Since we know that AP from the first triangle is equal to 5 and PC from the second triangle is equal to 10, then the ratio between AP and PC is equal to 1 to 2. That means the ratio of these two triangles is 1 to 2. So right now we are trying to find DE, and so if we know what DP and EP are, then we can find DE by subtracting DP from DPE. So we know that PE, since it is in the second triangle right here, and the ratio between these two triangles are 1 to 2, so PE is equal to BP times 2, since the ratio is 1 to 2. Now, similarly, since we knew that the triangle ADP and the triangle BPC are similar, then we know that AP over PC is equal to 1 to 2. Then we also know that the ratio between these two triangles is also 1 to 2, which means that DP over PB is equal to 1 to 2. So DP is equal to 1/2 of. So from these two equations, we can see that we can find PE and DP if we know what BP is. So what is BP? Well, this is where something hard comes in, which is called Stewart's theorem, which basically says that in a triangle ABC where BC is separated into M and N, there is this equation B squared M plus C squared N is equal to A times M times N plus D squared A. So I'm not going to go into how this is proven, but if you want to know, you can go on to the RS solving problem, and it has a full explanation on why this theorem is true. So using this theorem, we can find BP because we know all of these variables, and we are trying to find what AD is. Sorry, this is D right here. So since we're trying to find D, we can isolate D by itself and substitute all of the rest in. So B squared M would be equal to 14 squared times 5 plus C squared 13 squared times 10. And then you subtract A times M times N over. So subtract 15 times 5 times 10. And this is equal to D squared A. So if we divide this whole thing by a, which is 15, we get d squared. Now we can simplify, and so d is equal to 8 times the square root of 2. And so plugging this into PE, we get that PE is equal to 16 times the square root of 2, and that DP is equal to 4 times the square root of 2. So since we already know PE and DP, we can find DE by subtracting DP from PE. So 16 times the square root of 2 minus 4 times the square root of 2 is going to get us 12 times the square root of 2. And that is going to be your answer. Looking at the answer choices, we can see that the answer will be D, 12 times the square root of 2.